RISC-V instructions format. There are 6 instruction types: R, register type; I, immediate type; S, store type; B, branch type; U, upper immediate type; J, jump type. Let me brief what each type means. When we say register type, it involves 3 registers, 2 source registers RS1 and RS2 and 1 destination register RD. RS1 and RS2, they are going to be like operands. So whatever the operation that's defined by both function 3 and function 7, the operation will be performed between RS1 and RS2 and the result will be stored in destination register. That's why it's called as register type. This opcode defines whether it is of type R. And here if you look at all these registers, RS1, RS2 and RD, they demand 5 bits. Overall there are 32 registers. So we will try to use all the registers as either source register or destination register except X0. Always remember X0 is hardwired to 0. So we need minimum 5 bits to address 32 registers. And for function 3, 3 bits. For function 7, 7 bits. I type, the only difference is we use constant instead of RS2. So the operation will always be performed between source register 1 and the constant defined by 12 bits. That's why it's called immediate type. Function 3 defines the operation to be performed similar to our type, and the operation will be performed between RS1 and the constant and the result will be stored in destination register. In this case, we need to make this constant as 32 bits because RS1 has value 32 bits. So the operation is going to happen between the constant which is of 32 bits with the value RS1 which is of 32 bits. So we need to sign extend this immediate value. The sign bit will always be bit 31. All immediates are always sign extended and they are packed towards the leftmost available bits in the instruction, which is nothing but bit 31. So we are going to use bit 31 and we are going to do sign extension. S type means store type. We use this instruction primarily to write the values into register. Here the value is defined by RS2. The value is stored in RS2 and the address will be calculated from both RS1 and immediate value. So the address is going to be the sum of RS1 and immediate value. Again, we need to sign extend the immediate value, then it will be 32 bits. And then we will add this value with RS1 and the function 3 defines the operation. What type of store? We can think of storing word, we can think of storing off word. So that's defined by function 3. Next is B type, branch type. It will always check the condition using RS1 and RS2 as operands. RS1 is same as RS2 or RS1 is less than RS2. There could be different conditions. If the condition is true, then it will jump to this particular address, the address which is defined by immediate value. So here immediate is 12 down to 1. There are 12 bits. So we are going to sign extend the immediate value and then we are going to calculate the address. So if the condition is going to be true, then the PC is going to be PC plus immediate value. Else PC is PC plus 4. That's how branch type works. U type, upper immediate. whatever the constant that's defined by immediate value, that constant will be stored in the destination register. So basically we are going to load the upper immediate, which means we need to keep this constant at the MSB. So we are going to append zeros at the LSB. We will look at this later on. The last one is J type, jump type. So it's going to jump to a particular location and the address is defined by this immediate value. Here, if you consider all the instruction types, the source registers RS1 and RS2 and destination register RD and some of the fields like function 3, they have been placed at same location. Look at this. RS1 is placed at the same position for all instruction types. RD is placed at the same position for all instruction types almost. And function 3 again placed at same position for all the instruction types. So this simplifies the decoding logic. This is the advantage of a RISC-V processor. Alright,